So, what's in this box? Stick around to find out. This is a clue. Any more ideas? Now I've been asked to have a look at this thing. It's a repair, potentially, maybe. I've got no experience with this particular item, so I've got no idea what's wrong with it, what's potentially wrong with it. Completely no idea. We'll find out. That's the whole point of it, is to learn new things, and maybe it is easily fixable, maybe it's beyond repair. Don't know yet. Let's have a look. So we've got some wires. We have some cables and stuff for connecting it up. So we've got a main supply, which is hardwired, I think, and we've got this other cable here. Yep, there you go. So we've got this connection cable here for going out to whatever's controlling. Main supply cable, which is using one of those caravan type sockets. Exterior sockets, weatherproof ones. Obviously meant for outdoor use, there's another clue. Anyone got it yet? Here's a pair of cables, or two different cables for different kinds of functions. Different size plugs on. And here's the unit inside the case. Now I think this can be used in the case, but it does come out. AKA Fusion CB315-U Akatherm. It's an electrofusion unit. What it's used for is melting polyethylene pipes together. So here's a Akatherm pipe joiner, and what's inside it is basically a resistor. And what it does is those cables which I showed just now, I don't know if it's probably not, no it's not the right one, the other one, the other cable, this one here, that will plug in there, and this one will plug in here, and then this gets plugged into the other end of the long cable, which then gets plugged into the unit, and the unit puts power through it, heats up this resistor, which melts it, and melts the pipe as well, and melts all the plastic together to create one solid pipe in one solid joint. So there's no adhesives or anything like that, because polyethylene pipe, you can't glue it, you have to melt it. That's what this is for. So I've been asked to have a look at it because apparently it's stopped working, it's giving some error messages, and I haven't even powered this up yet, I've got no idea. And actually I can't power it up right now because I don't have a plug. Well I do, but it's not in here. I need to get an adapter, I've got it elsewhere. So I need to figure that out. I thought this would be an interesting tear down and potential repair, but really I kind of need to power it up before I open it up, in case it's something simple which is okay. Could be interesting. So make sure to subscribe, click the bell icon, that sort of stuff, and thumbs up. Don't forget the thumbs up. So if you like this kind of thing where it's a bit unusual, bit out there, non-standard repair stuff, because I get these weird things from time to time, you know, unusual things, not, you know, just test gear. Make sure you subscribe in case something else like this comes up. Who knows? If this is something which it turns out that I can repair without much hassle, it's possible I'll get more of them in the future. So we'll see. I mean, I don't know. Who knows? Who knows what's going to happen? At the very least right now I'm just having a look and seeing what's actually involved and what's potentially gone wrong with it. If I can figure that out. Apparently when these fail, normally they get sent overseas. Yeah, so they get sent overseas and then shipped back again. So that's a long, slow process. If it's something I can fix, then might be good. And here you go, here's the information about the unit. Ritmo, I think it is. I did see this mentioned somewhere online as well, Ritmo, as a manufacturer. I saw it mentioned as well. Exactly the same unit with a different name on the front panel. This is branded Akatherm, because that's a company which does pipes, supplies and stuff. Year 2015, June 2015, so this is 5 years old. You should think it'd still be working after 5 years, wouldn't you really? Apparently it failed earlier in the year. So the first thing I need to do is try and replicate the issue they were having. So we get this cable here, plug this in, the correct way around. It's a polarised socket, so male or female. And that goes in one way. Where is it? There it is. Come on, in you go. Kind of push it in. Okay, so that's the end in. And then we'll get the other end, put it on the adapter. Plugs in here. Look at the connections as well, make sure they look kind of alright. Right, so obviously this then goes on to a pipe fitting. I'm not actually going to try and activate this because that really isn't what it's meant to do. Well, it is meant to do this, but it's supposed to be on a pipe, so it absorbs the heat and melts the pipes together. So if I turn this on, probably briefly it's okay, but I can't do too much. Right, so if it even goes. So that's that. Now I can get the power hooked up. So this is the plug
and I've then got a caravan plug. It potentially draws 2.5 kilowatts, so it's a bit much for my system. So I have to plug it straight into something. I'm going to find something I can plug this in because it can't plug in over here. Oh, I've got power point on the other side of the room. We're going to plug it in there. That's plugged in. Power should be applied. Power switch is over here. We'll turn it on. Beeping with a little man icon. Okay, so it's first saying it needs maintenance or something, so that's a first clue about what's going on. Actually, can I stand this up and have you see it, maybe? Have you scraped, is that? Yep. And, wow, it's a slow read, isn't it? And the line pipes, yes. No. What the hell does that say? Oh, that's no connection. That's supposed to mean the fitting, I think. Okay, so it looks like he can't detect a fitting plugged in. So that's the first thing it does. It does an error check to make sure it's actually detecting there's a fitting there. So it can't see the fitting. So the first thing looks like it could be potentially a problem with the connections from here to here. So let's trace that through and see if we can find anything. So the first thing we should do is check this big cable in case there's a break in this cable. Since probably the most likely failure point, second to that would be obviously this one. So we'll check for continuity first, and we'll go connect to the connector, and it should just be a straight through. So let's get the pin numbering. Just look at that, it's in the side, the connector there. So yeah, pin 1 here, here's pin 1 here. So we should just be able to shove a probe in like that and get connectivity. Yep, that's working. So pin 2, yep, pin 3, yep, pin 4, yep. So that cable there is probably fine. At least whilst I'm holding it like this, it's okay. No obvious breaks. So that rules that one out. So the next thing is to check this cable and see if this one works. Now it's got obviously 2 connections here and 4 here, so I don't know which ones it actually goes to. Let's try and just take a guess, shall we? Is that pin there, which I think was pin 1, wasn't it? Pin 2? That's pin 1. So that's going to pin 1. This one here is not going anywhere. Okay, so that pin there, that one's got no connection. So, okay, let's look at the other cable. I don't know if they've got different pinouts for different plugs. They may do. Depends on if they're using it as some kind of way of determining what kind of connection they got. They may do. Show that in there. Pin 1, pin 2 is used. And this one here might be pin 1. It is. So this should be using pin 1 and pin 2. Alright, at least this one's using pin 1 and pin 2. So this one here should probably be using pin 1 and pin 2. So this one should be on pin 2 as well then. Presumably. Definitely nothing there. So it looks like this is what's wrong. No connection. That's pretty simple, isn't it? So let's pull apart. How am I going to pull these apart? I'll pull this one apart. And then we'll see if this end looks like it's been pulled off, because it's going to be one end or the other. This is a gland. Now this will unscrew off here, but these can be a bit of a pain, because you've got to unscrew from this piece here. I'm used to these connectors, I've seen them before. Okay, I'll just plug it into the other one so I can use that to hold it and unscrew from there. You see I'm actually trying to avoid spinning that in the gland too much. It should go with it. There we go, that's now off. Let's pull the plug out. Should be able to push it out. And there's the 2 connections. There's a loop here between those 2 pins. They're looped. So obviously a confirmation that it's plugged in, I'm guessing. There's actually something in there. Is that a diode or resistor or something in there? We'll measure that in a second and find out. And then the two wires are attached in here, but not very well. They're a bit frayed. They're in a bit of a mess actually. That means it's likely your wires come off this end, because at least they're actually in there. So let's find out what's inside this mystery device here. Is it a diode or is it a resistor? Both the same way, both ways it's the same, so it's probably just a resistor in there. Let's measure it. 47 ohms it's measuring as. Right, 47.4 ohms is the measurement I'm getting on across there. Let me check the other plug and see if that's doing exactly the same thing. Maybe it's a... I'm trying to figure out how these things work as well at the same time. Same two pins, 472 ohms. So there's a 10 to 1 difference between these two plugs. So yes, it is using the plugs to determine what type it's got connected up. So 47 ohms for the yellow, 470 ohms for the blue. Good information. And just to verify, this is the one that's going to that second pen. Get my leads tangled up. So no connection on that wire there, and swap the leads to the other one. No connection to that one. Go to this terminal, and that's that one there. Should be working. There we go. That's okay. And the other lead, nothing. So yeah, definitely got a broken connection between here and this plug. Alright, so let's pull this apart and actually have a look and see what's going on. Gland. That should move freely. Yes, it does. I can't. This is all solid, so I can't see anything there. Ah, there we go. Alright. So inside there's nothing, just a housing. And inside there is the wire soldered on. And the solder connection looks fine. Let's check the wire again. Back to pin 2, which was down there. It's pin 2 here. Shove it in. Hold on to that. Oh, it's fallen out. Might have to clip it on. Well, it's definitely an open circuit. It's definitely an open connection between those two connections. So there must be a break in that wire somewhere, which is really interesting. There's little nicks on it just here. Just looking for any signs of being compressed. I mean, obviously here where the gland is, but I don't know, maybe. That actually feels... That feels stiffer here. So what? See this little bit here, which is sucked in? It's about there. That's okay, that's where the gland was. But it feels stiff there. And normally when you get a stiff bit, it usually means that it's got hot and partially welded itself. Maybe. I could be wrong. So having a close look at this end, you can see it's actually got a big flat in it. See that? It's been pinched. It's been squashed right there. And that's just outside of where the gland is. So the gland actually stops short of that. And even this one here has also been pinched. See that? So what I've done is I've put my clip lead up onto here, onto the multimeter. So I should be able to touch those together and get something. There we go. Alright, so that is working. Let's see if I can get the wire to behave and get a signal from it. Nothing there. Okay. I was trying to find whereabouts in the wire the breakers. Well, it's just completely open. It really just doesn't want to go. It's probably due to the currents involved, because it's, you know, quite high wattages, so it's a good chance that it's just basically acted like a fuse and burnt itself open. So when you get a really bad connection, it will heat up. Alright, so you get a bad connection, it will heat up and then it will just expand. So that's like a fuse, and it will just pop open. So I think that's what's happened to this wire, is it's got an internal break, and then somewhere around there it's acted like a fuse and just opened up and increased the gap within the wire. So yeah, I can't seem to see where it is exactly in that wire, but this looks like it's a double insulated wire. It's got a silicon sleeving over the outside, it's got another wire there in the middle with the actual conductor, and then there's a silicon sleeve over the outside. So it's double insulated. I haven't got any of that kind of wire. So what I can do is a test, only as a test, to see if I can identify this. I'm going to connect this back up again. Obviously not the wire which is broken, so I'll shove that back in there. I'm not going to turn it on because this will not handle the power. Right? This will definitely won't. This is only going to handle a couple of amps maybe. Alright, so not 10 amps. What I'm going to do is I'm going to hook this up to the plug and connect it all up, and we shall see if it can then identify that it's plugged in, if I bypass that wire and go straight to the actual element. Okay, just to determine if that's what's wrong. Okay, so we'll plug that in. Now also this is potentially high voltages. I think it can do up to, well, it does up to mains voltages on here. For the bigger fittings, I think this is reduced voltage on this, but still probably kind of dangerous. So I'm not going to touch anything once I've got it hooked up, okay, or powered up. So let's get this connection here. I mean, these need redoing. These are awful. They need redoing anyway. So we'll hook this up. Make sure I've got on the right wire. I do. That's a 2mm fitting, so that plugs in nicely. That's on there. Let's move this out of the way. Let's get this in position before I turn it on. Then we can see what's going on. See if anything's changed. Alright, powered up. It could go bang, who knows. So we've still got that issue. Have I checked it? Yes. Stop. That's working. So that's fine. That actually turned on then. So that is actually working. So it didn't register a fault anymore. That was then connecting. So all it is in this case is a cable. This dodgy cable here. So cool. So it's still got that error message coming up on the screen there saying about needing servicing. Yep, it's barely warm, right? So it did put a little bit of current through it, but not enough for a long enough time to actually cause a problem. Alright, and unplug that. Yeah, there's no warmth in that. Didn't get anywhere near it, so that's good. But this is why I wanted one of these fittings, so I can actually test as well and actually verify what's going on. So yes, dodgy cable. Simple as that. See this bit here where it's compressed right down, where it's squashed down? That is the bit where it's failed. I got in here and I was able to twist it and it came on and beeped. So right there is where the failure point is. And it's almost in focus. So I've cut the wire off, and sure enough I cut it right on that depressed part, and yep, there's a break right there. As I went to strip it off, it pulled straight off with a piece of wire still on it. So yep, I was exactly right, that is where that break will be. I can actually verify this just to be absolutely sure before I do this. Let's hook it back up to that pin 2. I've already reconnected the other end. Put the meter back on. Touch it on here. Yep, that's working fine. So definitely right. I've located the break in that wire, and I'm going to try and reattach it onto here. Now this is all just soldered into this big copper fitting here. It might even be brass, is it? I don't know. But anyway, it's soldered in there. This is going to be a mission trying to get this joined up. I've got to obviously try and desolder this out of here, but that is going to be really hard to desolder. Now I do have a hot air station. I might have to use hot air and soldering iron at the same time. I don't know yet. I'm just going to put some solder on this first, and let's get this ready. Alright, that's the wire ready. It's a silicon wire, so I can take quite a bit of heat anyway. Obviously it's meant because it's a thing which uses heating elements, so therefore it's done for protection. I don't want to be holding on to this in my hand, and let's see if I can melt the solder. I might have to use my hot air as well, just to give it a bit of extra
power, but we'll see how we go. We'll see if this can do it. I think I'll use hot air as well. This is really struggling, as expected. So let's get my hot air station going. We'll hit it with this. And just give it some more power. Go. We did desolder then. No. And I'll put some fresh solder in. And leave it to cool down. Clean this up, a bit messy. Better. There we go, resoldered. Now I need to let it cool down before I can touch it again. Could be a while. Right, let's just put back together, let's hook it back up again and we'll try it again. See if we've resolved the problem properly or not. So this should, don't forget, get quite hot. So I'm just going to do it for a short time, then off again. I don't want it to melt. Right? I want to give this piece back intact. I don't want to actually use it. Alright, so turn the power back on. So we've still got the little man thing because I haven't done anything about that. Right, so it says, have you done it? Yeah, sure I've done it. Yep, that's working. Error 55 because I've stopped it. Let's unplug it. Is there any warmth? Yep, there's a little bit of warmth in there. I'll just throw a bit of ambient warmth in there. Yep, that definitely put out power. That's definitely working. Okay, that's some progress. So that is actually essentially fixed. It's just got that servicing message on here now. The question is, how do you clear that? Interesting. So if I hold that button down, it causes it to do that. It's kind of self-destruct, is it? I don't know. Because if I design something like this is what I'd do, is I'd have a hidden button combination. Did I do that one? I can't remember. Right. Okay, well, I tried a few button combinations. None of them seem to do the trick, so at least we've made some progress. This is kind of fixed. Just that servicing message. I need to figure that out. Maybe I will. So the next thing is we should really have a look inside this and just see what's in it. Maybe there's a reset button in there or something for the maintenance. It's all sealed. Obviously they're very worried about this. That is actually not that hard to get around. So let's get around it. Guess I spoke too soon. This has actually got a void marking in here. So if you try and take them off, you get a void shows up. So I just done that corner there a little bit and it started showing. It's like, okay, that's not going to work. Usually you can get a razor blade underneath them and you can lift them up and the whole void thing will come with it as well. but in this case it's looking like it's going to be a problem. Now they were going to remove this thing from service. I think I might open up anyway. I'll see if I can get this off and again, but if I can't, then oh well. I've only really got to do one side. I think if I just undo these I might be able to flip it over. I guess we'll find out. Yeah, it's better. Right. Actually, you don't need to see this whole thing. So here we go. That's the inside of it. I ended up having to lift the whole thing off. I probably should have taken off this side, not the other side. But anyway, never mind. It's off now. They were going to say take it out of service anyway. So we've got a couple of current sense inductors there. So ferrites. So these are measuring the currents. Got a earth point there. Transformer here. Or something. It's actually two wires going to it. 1.3 millihenries it's marked as. It's going from the main switch through back out. So this will be a filter then. That's just a filter. Okay. So in here we've got a couple of little smaller transformers in there. A couple of relays, 12 volt relays. Microcontroller over here. The backup battery. 8 megahertz crystal. There's a couple of adjustments just over here. One's marked V, one's marked Contra, which is probably contrast for the display. These wires solder straight on instead of having spade terminals. Let's just get a closer look. There you go, slightly better. So you can see there's nice. You've got spade terminals there, but they've got them soldered straight in, which is an interesting difference. A few filtering capacitors and stuff like that in there. There's a fuse here, fuse here. Probably one's doing the actual control circuitry, one's doing the actual output because it's high current output. Microcontroller, I'm just trying to see what that is. It's a bit of a mess in there. Let me just get a bit of cloth on it and just give it a wipe. See if I can see what it is. It's like an STM32 or something like that. That's a PIC. It's a PIC microcontroller. Right, okay. And it's got a programming header just here, so it's possible that they reset it in the PIC by communicating with it through serial or something, but I don't know. I was hoping to see like a reset button or something in here. I haven't identified anything yet. It could all be done through serial though. Maybe use a bit of software to communicate with it, because there are serial connections over here. Oh, you can't see half this. Yeah, that's a bit of crap. They're using a PIC over here, PIC microcontroller. I was hoping to see a button or something like a reset, something simple for maintenance. You know that when it goes to the factory, just push a button, it clears it. But apparently not. So it's probably going through some serial connection in order to control the PIC. I mean, I haven't noticed anything. Maybe there's some pads they short or something like that, because sometimes you get like reset pads. Just having a close look, see if I can see anything. Because you've got a UART connection over here. And it's also this thing here, in case you're wondering, is a thermocouple, which is falling out. Ambient temperature sensor. It's supposed to be pushed through here. That needs to be put back into place. Like that. Yeah, I'm just trying to see if there's any obvious way of doing a reset on this thing. So the PIC's basically driving the display. Just like driving it directly. There's a lot of flux around there. I'm quite surprised how much flux is still on the board. It's not been cleaned properly. We'll set there 705 voltage regulator just here, U10. Capacitors look alright, no obvious signs of bad caps, so that's always good. I might check that battery, see if the battery voltage looks alright. Well, the battery measures 3.2 volts still, so that's fine. It's still got plenty of life left in it. So that's not a problem with the maintenance issue. E3 here is an auto coupler, so we can see there it's like diode bridge potentially there as well. Diode bridges here from those transformers. Local power supplies. Yeah, there's no obvious easy way of resetting it. So I'm actually very tempted to hook up to this programming header over here and see if there's any data coming out of the PIC. It may be that it sends out information through the serial on its own programming header there. That JTAG, whatever it is. There's also the serial connection over here, which I think is just a printer output, but maybe it does other stuff too, and maybe it might be worth having a probe around on that too. So I measured 3.2 volts over here, so it's definitely a 3 volt based system, not 5 volts. I have to make sure that anything I do is based on 3 volts. So I might do that. I'm actually very tempted to try and have a poke around on there and see if I can get any data out of it. Knowing how to reset the maintenance menu would be quite handy. So I'm playing around trying to figure out codes on this thing, and the manual does mention some codes into this menu over here, which you get into by pushing the stop button. Actually, I'll go in there. Alright, so there's main menu there. Push the stop button, you come into this other menu, it's got some options in here. And other functions, you get to put things in. Right, so I'm guessing that this menu here will also allow for the resetting of the maintenance flag. Right, so I'm guessing there's a way through here to do that. Now, one of the menus says 2110, which is to reset the print flag, or well, the welding history, the reports. Right, it does a report for each weld apparently, stores them up. So you can reset that using 2, 1, 1. Right, it's supposed to reset the welding flag. So, well, I was looking at the code. It's got 1000 series, there's a couple of things, and you've got 2000 series just by itself. Thinking, okay, well, let's try another random code. So let's put in 211, an extra 1 in the end, which isn't documented. It does something. Don't know what. If it's an invalid code, it says that. So 2111 does something. I've got no idea what it's doing, but I think it's resetting something. You know, doing 2111 hasn't reset the maintenance menu. The maintenance alarm still comes up. So it didn't resolve that. But I think I'm onto something there with that 2111 or the 2000 series being reset menus. So I think I might carry on that vein in the 2000 series, possibly even the 3000 series, because 1000 is basic functions, 2000 is a reset of some kind, maybe 3000 is a maintenance menu or admin type menu thing, possibly. I'm just trying to keep things in the same vein of how they would have designed it. Obviously I'm just guessing here, but I'm trying to stumble across the menu or the option which will reset the maintenance flag. It must be in there somewhere. Right, I've had a look at the board, I've done a physical check on the board. There's no reset or anything on there, no button to push, nothing like that. So therefore it must be through this menu system. I'm going to spend some time on that and try and figure out how to do it. Okay, I had some intuition just now. I'm going to show you again. Other functions again. Code of 2009 brings up this. Matricola. What does matricola mean? Might have to look that up. Apparently as far as conversions, it's Italian I believe, matricola. Matricola means number. So how many digits is this? 2, 4, 6, 8, 9 digits. So is this where we put the registration number in for the unit? For the serial number? 2, 4, 6, 8, 9 digits. I think this is where the serial number's put in. So I think matricola means serial number. So if you need to change the serial number unit, I guess that's how you do it. I could try changing it and see what happens, couldn't I? Let's make it a 1. Accepted it. Let's go to information. I'm right. There we go. Serial number's been changed to 1, whatever the hell that is. So yes, I changed the serial number. So 2009 allows you to change the serial number. Also, just found this code reset something too, 2100. That also does a reset of some kind. Or does something. Let's see if that does it. Let's go into information. I've got to change the serial number back, mustn't forget to do that. Actually I should do it now before I forget. No, that didn't fix it. It's not 2100. We keep looking. Okay, I just found another hidden menu. Get in there, so 2207. You can see right there. Gives us this. Seems to be giving us line voltages. And it's detecting it should be within this range. So this is like a testing menu. Terra Tua, is that? V Rati? I should probably go and translate this. 8465 is probably analog to digital value. So yes, that's giving us line voltage. There's no signs of adjustments. So if I can only do OK and get back out of it. So that's 2207. Getting there. So translating this is in Italian. So it means the network calibration. Just like that's for checking the line voltages to make sure it's accurate, as I suspected. So this menu here, which is 2218, it displays this Gallardo analog, which translates to analog testing. And this value here changes depending on what lead you're plugged in. So this lead here is the yellow one with the 47 ohm resistor, and if it's open circuit it gives 1023,
digital reading. This gives about between 4 and 6, and the blue one gives about 63 to 65. Floats a little bit. But there you go. So that's its input from the resistors in those leads, which I measured before on pins 3 and 4. So that's verifying that those leads look okay on those resistors. Keep looking. So I found a whole bunch more menus in this thing. I can change the branding on it and things like that, so I've made a note of all those. Actually, I should mention it in the video. So if I do 0122, the branding changes to Ritmo. If I do 0233, it's Akatherm. If I do 0344, it's Valsir. And if I do 0455, it's blank. No model number, no branding. So those are the branding changes I've found. There's also an Easter egg in there. So 0101 brings up the name of the person which actually designed it. Found some other resets. There's a full reset as well. Completely resets it, then you have to do some other stuff. Resource to default, which is 1333 is the one that does reset default. There's also 1400, which says wait for writing to USB memory. And there's 1970, which says press OK to start calibration. And I haven't pressed OK. I've left that alone. I'm not sure what the calibration criteria is supposed to be, so I don't want to risk messing up the one that's already in here. I think that doing 2100 reset the maintenance alarm after I'd done 0122 and then 1333 and then 1100. I did those three, and then I did the 2100, and then I noticed the maintenance alarm had stopped. So one of those resets, and possibly the sequence of those resets, cleared the maintenance alarm. Through from 1000 to 3000, done every single code, and I'm working through now from zeros through to 1000 to fill that gap in. So now I would have done from 0 to 3000 codes and found everything that's in there. Anyway, what I wanted to comment on was on here, I did show you this before. This is the voltage measurement on here. Alright, so you can see it's showing volts RMS 215. Well, the actual volts right now is 228 to 230. So it's actually reading a bit low. Now you notice here the range is 208 to 235. So it looks like this is based around a 220 volt system. And so it's been calibrated downwards to make it think it's within that range. There's adjustment inside it, which I think is what does that. I haven't tried that yet. I did point that one out before, that multi-turn pot is in there, blue trim pot. So if I change the voltage on here to get to the maximum it's supposed to have, which is say 235, you know, slightly better on it. There you go. Alright, so I go up to about 235 on here, which is the maximum it's supposed to allow for. Right, it's about there somewhere. That's 250 volts AC coming in reality. If I go down to the lowest one, which is 208 on there, let's put this calibration set point there. There we go, 208. That is 222 volts coming in, or 220 to 222 coming in. Okay, so obviously it's been shifted down to make it think it's on a lower voltage when it actually isn't. So that's something to watch out for, trying to do adjustments on this in the future, that this actually reads below the actual set voltage, because it has to be within this range. You've cheated a little bit there instead of adjusting the actual tolerances. So if I turn it on now, there you go, no alarm, got the Akatherm branding back on it again, so I can change the branding. It's got a few different firms in there, so it's obviously a company makes it and then sells a few different companies worldwide. Anyway, we're getting there. I'd just like to go through the rest of these codes and find out what else is in there. So just for reference here, this particular fitting here, it measures 20 ohms once I get the probes on. Get the probes on. About 20 ohms or so. So I'll call that 20 ohms. That's what the resistance is expected to be on here. Next thing I need to do is measure voltage that goes into it to find out how much power it's putting out and calculate that. Well, I'm going to try and measure voltages coming out of this thing into this coil here. Alright, so I'm on DC first, see if we get any DC voltage. Nope. It's obviously AC. Okay, let's try AC. See what we get. Okay. So that's 95 volts AC on a loaded coil, 20 ohm coil. So now we know what the voltage is, we know what the resistance is, we know what the power is. At least we've already once to calculate it. Okay, so according to the calculators, the resistance of this coil with that voltage across it, it's 4.75 amps and 451 watts is the consumption into this coil here. I've got a baseline, that's great. Obviously a different one will be a different potential resistance. If the resistance of the fitting is different for different sizes, because it might be a different length of wire for example, then also it's going to change those ratings. So if it's got less wire, it's going to be a lower resistance, so it's going to be more power. Potentially, I don't know. It may be they put less windings in. I have no idea. But or they might put more windings in, or a different kind of wire to change the resistance. I actually only have one sample fitting. I need to take some more samples of other fittings to work out what they all do. I shall have to look into that. Well, I think I'm done. I've achieved what I wanted to do. Cleared the maintenance alarm, figured out some of the menu system. The main thing was to try and reset it, and that's what I was actually trying to achieve, and just found this other stuff in there. I've now done from 0 to 3,300 in the menus. So I'm a third of the way through the menu system because it goes up to 9999. I don't know if there's anything even up those other levels, but anyway, it's done. It's working. Hope you found that interesting. I certainly did find it interesting. So this affects the Akatherm CB315-U. It's also the Ritmo, which is called the Universal 315 version 1, and also the Valsir, which is also called the Universal 315 V1. So it's got 3 brands built into it. So another little test I'm going to do in here is I'm substituting resistance values across the input terminals on here to determine what resistance ranges it will work with in order to identify the cables and hence the connector it goes with. Alright, at 150 ohms, let's plug this in. This says open, no connection. Alright, if I do 140 ohms, it says A00. So it seems that anything below 140 ohms is going to come up. So if I do say 145 for example, let's see what that does. Still says A00, 147, A00, 149, no, still open, 148, no, 147, yep. So anything below 147 ohms it considers as the A00 assembly. I don't know if it will go to anything else if I do a very different value. So let's do 10 ohms, see what comes up. It says open, detects it as a fault. Okay, so the other end of the scale here, so anything below 43 ohms, let's say it just recognised there 42, get down to 40, I had it working just now, then it didn't do it again. Yeah, so 40 ohms, it's not registered, it's things that's not plugged in. So it has to be between, say, 45 ohms and, what I say, it was 140 ohms, was it? In order to recognise the thing plugged in. Let's do 140 again, that's in, 150. No, okay, so yes, it has to be between 43 ohms and 150 ohms in order for this cable to work, for this unit to accept it as an A00 probe. Okay, we'll keep trying, we'll see what else we get now. I want to see what the next probe is up, and then the one after that. So I know it did 470 ohms on the other one, so we'll check up there. So another thing I've noticed as well is on this screen, which you can't really see because I've got it positioned weirdly, is once it's actually detected a probe, it doesn't rescan it. It thinks that's it, it's got that one. It doesn't try again after that, which is interesting. So I'm trying to find the A01 probe. So I'm at 320 right now, and it's not there yet. I know at 340 it came on, so I just want to find a point where it actually registers it. Oh, there we go. So that's 328 ohms. 328 ohms. So you could say 330 ohms is the bottom end for that A01 probe. So this has definitely got lots of capability. I'm trying to find the limit from where the probe type, or the coupling type changes. So that's 670 there, so that's, was it 330 bottom end, 600 and something top end. That's 620, let's try 625, sorry 650. Yep, 650 is open. There we go, 620. So 330 to 620 ohms are the A1 probe, 801. So let's try and find the next one. 700, so that's off. 900 A02. So let's bring it down a bit. Try and find that point where it kicks in. A02 is at 850. Okay, there we go. And I'll bring this up. Just there. Okay, so that is 829. So I call it 830 ohms. Okay, 830 ohms is the bottom end of A02. Okay, so I think if I do 999, or 990 ohms, see what it does. Still A02. 2K is open. Right, this is A03 there. Right on, let's try and find this top end of A02. There's 2 there. So it's 1.2K. Let's try 1.25. There we go, 1.21. 1.21K is the top end of A02. So I've gone through and checked every single possible resistance range of this single handle, and for all the ones it responds to. So the A00 is between 43 ohms and 119 ohms. A01 is between 311 ohms and 625 ohms. A02 is 830 ohms to 1.21K. A03 is 1.36K to 1.8K. A04 is 2.04K to 2.36K. A05 is 2.81K to 3.65K. A06 is 4.15K to 4.7K. A07 is 6.27K to 7.17K. And A00 plus is 7.25K to 8.9K. And that's it. There's nothing else after that I could find. Give us a thumbs up, subscribe, click the bell icon, all that usual stuff. And if you like the video, share it. I guess, I don't know, it's a bit interesting, I suppose. Something a little bit different. Catch you later. Thumbs up. Bye.